right, lesson 413, understanding quadrilaterals. Today's objectives, we're going to use properties of a figure to identify the special type of quadrilateral it is. You got to remember with rectangles, all four angles are congruent, and that's just the definition of a rectangle. Diagonals are congruent of a rectangle. And one last thing you got to remember, if a parallelogram has one right angle, then all four angles are right angles. And that makes it not a parallelogram, a rectangle. Now, when you have a rhombus, two consecutive sides are congruent, okay? And, which, by the way, they're all congruent. And the diagonals bisect the angles. So that's going to make, remember, when you bisect, you're cutting something into two equal parts. And then the diagonals are also perpendicular. And I don't think that I have this on here, so let me put it right quick. Let me get my pen going. Okay, so if the diagonals are perpendicular, that means they're all right angles. And then what they're saying is that you got two consecutive sides that are congruent, but just an FYI, all the sides of a rhombus are congruent. Okay? And then if your diagonals bisect your angles, that means, let me see, how am I going to write this? Angle BAC is going to be congruent to angle, making sure I'm writing this correctly, DAC. And your opposite angles are always congruent because remember, a rhombus has all the properties of a parallelogram. Okay, and remember the parallelogram, opposite sides are parallel and congruent. So that means I got some parallel lines going here. Okay, and that the diagonals bisect each other. So that means I've got some congruency going right here. Let me see. Opposite sides are parallel and congruent. Consecutive angles add up to 180. So that means that angle A and angle B are going to add up to 180. Diagonals bisect each other. And I thought there was one more, but I can't think of it right now. So in addition to that, they're saying that the diagonals bisect the angles and the diagonals are perpendicular. So just, you got to remember all these properties. Okay, with the square, remember it has all the properties of a parallelogram. Okay, but watch this. Since a square is both a rectangle and a rhombus, I only need, well, let me tell you that when I get finished with this other. So all four angles are congruent, and that's just the definition of a square or a rectangle. The diagonals are congruent. Hello, it's another property of a rectangle. And so what I did was I put this little bracket saying, hey, these are the properties of the rectangles. And now watch this. Two consecutive sides are congruent. The diagonals bisect the angles, and the diagonals are perpendicular. Those are all properties of a rhombus. Okay, so here you got a square. Remember, it's got all the properties of a parallelogram. So that means opposite sides are congruent and opposite sides are parallel. And then remember, in a parallelogram, we learned that the diagonals bisect each other. But remember, with a rectangle, the diagonals are congruent. So when they bisect each other, that means all of these segments right here are going to be the same size. Isn't that cool? And then two consecutive sides are congruent, and I've kind of already got that marked. The diagonals bisect the angles. Okay, and with the square, all of your angles are going to be 90 degrees. Okay, so if they bisect, that means all of the bisected angles, and here let me go ahead and bisect that. Okay, they're all going to be congruent. They're all going to be 45 degrees. And get this, the diagonals are perpendicular. So a square just takes it all in. If you were to take a parallelogram and put it with the rectangle and then put those two with the rhombus, poof, you're going to get a square. Okay, had a little bit of fun with my square there. Okay, okay, if either of the two rectangle properties applies and any one of the three rhombus property applies, then it has to be a square, just so you know. Okay, so if a landscaper arranged some plants and shrubs, and look at that, my little things popped up when they weren't supposed to. Hold on. Okay, now if a landscaper arranged some plants and shrubs along two intersecting diagonals in the center of a lawn, how could you use the diagonals to determine what the shape of the lawn is likely to have? So I got to reinstate my pen here because I had to fix my pop-ups. Okay, so he's got these bushes. Okay, how do you like my bushes here? I didn't want to just draw circles because bushes have leaves and they're not perfect circles. Okay, so if he arranged them just like that on his lawn and somebody said, hey, I can tell that that's making a parallelogram, but what kind is it? And you could say, you know what? I learned this in geometry. So let's check it out. If the diagonals only bisect each other, then it's going to be a parallelogram or a kite. If the diagonals are congruent, then it's going to be a rectangle or an isosceles trapezoid. And we haven't talked about that in a while. And if the diagonals are congruent and they bisect each other, then it's going to be a rectangle. If the diagonals are perpendicular, then it could be a kite or a rhombus. And if the diagonals bisect at least one pair of the angles, then it could be a kite or a rhombus. And if the diagonals bisect both pairs of angles, then it's definitely going to be a rhombus. And if the diagonals are perpendicular, bisect both pairs of angles, and they're congruent, you got a square. Okay? So you need to really pay attention to your properties and know what they are so you can determine what shape the parallelograms are going to be. Okay, here's another one. If SPQR is a parallelogram, PQ must be congruent to. Now then, what you need to remember is that we name our vertices in consecutive order. So there's point S, there's P, there's Q, and there's R. So they're saying, what is PQ going to be congruent to? Remember, parallelograms, opposite sides are congruent, so it's going to be congruent to SR. So you would just put SR up there in that blank. Alright, let's try another one. If AC is perpendicular to BD, parallelogram ABCD must be a, now I've kind of already drawn it, but we're not sure what shape it's going to be, but we got a pretty good idea just looking at it. But remember, you name your vertices in consecutive order. So there's point A, B, C, and D. Now I'm going to put my perpendicular segment AC and BD. So there's segment AC and there's segment BD, and since they're perpendicular, I put my little square there showing I got a right angles. Okay, so you go back and you think of your properties. When do I have perpendicular diagonals? And I just flicked the wrong slide. Okay, so whenever you have perpendicular diagonals, you could have, and they don't give me enough room to write, a rhombus or a square. Okay? And remember, a kite, you would think kite because you know its diagonals are perpendicular, but a kite isn't a parallelogram. Okay? It kind of falls in there with the trapezoids. It's special quadrilateral. Okay. Oh, another proof. I know you're pulling your hair out over these proofs, and I always try to include some because I want to go over them again and again and again until you can do it on a test and make 100. Okay, ABCD is a rectangle. That's a given. Okay, we've got to prove that triangle EAB is congruent to ECD. They've already filled in the statements for us. We just got to give the reasons. So we know that AB, because if we got a rectangle, we know that our opposite sides are going to be congruent. We also know that our opposite sides are going to be parallel. Correct? So, hello, it's a rectangle. And I just told you opposite sides are congruent and parallel. So that's all you got to write in there. Opposite sides of a rectangle are congruent and parallel. It's a property. Okay? Remember, a property is a rule that you can use in a proof. Okay, the next statement says that angle EAB, oh, that's right here, is going to be congruent to ECD. Well, you got to think about this, okay? AD is parallel to BC, and then here you've got segment AC. That's a transversal, okay? So that means I've got some alternate interior angle theorem coming into play here. Okay, alternate interior angles are congruent. Now it says angle AEB, that's this one right here, is congruent to CED. Ooh, that one's an easy one, okay? Because we've talked about that one a lot, like since Unit 1. We know that vertical angles are always congruent. Okay, so that's the vertical angles theorem. Now they say, well, we're going to go ahead and we're finished with our proof. So triangle EAB is congruent to ECD. So let's look at what they're talking about here. Let me get my highlighter instead of using my red pen. Okay, so I've got to identify my triangles here because that'll help me. Whoa, that's a real dark yellow. Okay, they're saying that these two triangles are congruent. So, how do I know that? Well, let's look at what I've proven. I've got these sides right here are congruent, and then I have an angle and an angle. So side, angle, angle. Cool? So now I just push my little clicker and AAS pops up. And that's how we know those triangles are going to be congruent. Okay, when you get finished watching this video, oh no, I'm trying to get ahead of myself. A parallelogram must be a rectangle if one of the following is true. One angle is a right angle, or the diagonals are congruent. Okay? A parallelogram must be a rhombus if one of the following is true. A pair of adjacent sides is congruent. Adjacent, remember, means right next to each other. You could also interchange that with the word consecutive. Okay? Consecutive says one's following the other. Or the diagonals bisect the angles, or the diagonals are perpendicular. A parallelogram must be a square if it has one of the following. One property of a rectangle from above, and one property of a rhombus from above. Ta-da, you're going to have a square. Now, after you get finished watching this video, you should read through the lesson 413, Types of Quadrilaterals, and complete the student guide. Add any notes whenever you read through the reference guide. Complete the following problems in the problem set. And if you still don't understand these concepts, then you need to contact me or attend TOGA if you have any questions before you complete the quiz. And as normal, just make note of any general questions that you may have for when you attend CC. And remember, to contact me, the best way to do that is through Yahoo Messenger. And when you do contact me, or if you contact me, please give me your course and section number with all communication, so that way I can help you faster. Well, that's going to be it for lesson 413. Thanks for listening.